Today's lesson has to do with attributes of transformation of cubic functions. We have a cubic function here. So it says a graph of the parent function f of x equals x cubed is shown at the right. The other graphs are transformations of the parent function. Which equation goes with which graph? So what we're going to do is we're going to try to match one of these equations to one of these. Okay, so what I'm going to do is I'm going to graph each of them. So I'm going to go to menu, graphs, and I'm going to start with the one on top. So we have parentheses x minus 3 to the third power plus 2. And if we were to guess what's going to happen, that plus 2 means it's going to go up. That minus 3 is going to shift to the right. So let's see if that's going to be it. So it appears to be this one right here. So for right now, what I'm going to do is I'm going to match these two. This x plus 3 let's go ahead and do that x plus 3 to the third power. So I'll go to menu, tab, graph, function. So I have parentheses x plus 3 raised to the third power. And that should go right and then go minus 2, so it goes down 2. This one appears to be this one, but we're just going to be checking. This last one, what I'm going to do is I'm going to go to the menu, graph. This one says negative x to the third power, and it does switch directions, so I'm going to assume that this one is this graph. Let's go ahead and graph x minus 2 raised to the third power plus 3. Parentheses x minus 2 to the third power plus 3. Yeah, this one doesn't match any of these three. This one is a parent function. We can see that right now. We can maybe do it. Press tab, x to the power 3. That's a parent function. And then the last one, I'll go ahead and let's go ahead and do a new graph. So we have parentheses x plus 2 to the third power minus 3. Enter. Yeah, so we I think we matched our graphs. So this one here, it's plus 2. It goes up and it goes to the left. So it's going to be this one. X plus 3 is going to shift to the left. It's going to go down 2. Negative is going to reflect over the x-axis. Let's go ahead and do problem number 1. It says, what are the minimum and maximum values of this function f of x equals x cubed on the interval -4 to -2? So let's go to make a table. We have x is -4, -3, -2. So let's go ahead and go to the calculator. We'll go to menu. Let's go to the on, new, graphs, and we have x to the power 3, which is the parent function for a cubic graph. Let's go ahead and go to our table. And if we scroll to -2, we have -8. If we go to -3, it's -27. And if we go to -4, it's -64. So if you want to know what is your minimum point, it's -4, -64. If you want to know your maximum point, it's -2, -8. It says, how graph each function on the same set of axes as a parent function. How does the y-intercept change under the transformation? So I've already graphed the parent function. I'm going to tab it, and I'm going to graph the new function. If you notice, you can't see the function. So what I'm going to do is I'm going to adjust the window. So I'm going to go to Menu, Settings. I'm sorry, you're going to go to Menu, Window, Settings, and I'm just going to make my Ymax 100. I just want to see what's happening as I increase values. So Menu, Window, Window Settings, the Ymax, I'm going to make it 100. Enter. Now you notice this is the parent function, this is the new function, and you notice that the y-intercept does increase. So how does the y-intercept change? Will move up or increase. Okay, we're going to identify how does the y-intercept change in comparison to the parent function, and we're going to have the new function, which we have x to the power 3 minus 1. Press enter, and you notice that this is the parent function, this is the new function. So what happens? The y-intercept will decrease, or the y-intercept will move down. Let me just go ahead and erase it. The y-intercept will move down. I've decided to combine lesson 10.1 and 10.2. So we're just going to do two examples from 10.2. We're going to grab the cube root of x minus 2. So remember that we're going to go ahead and make your y-axis, make your x-axis, and by just looking at the table, we'll go to Menu, Graph, actually Table Split Screen, 1, -1. I'm going to move up 0, -2, -1, -1, -3. So if I look at it, it sort of looks like this. We're going to identify the domain. And the domain, remember, is a set of all is a set of all x values, so the domain will be from negative infinity to positive infinity. The range, if we go all the way down in the y-axis and we go all the way up on the y-axis, it's going to be all real numbers. The only thing that I want you to think about is the y-intercept. In this case, the y-intercept is -2. We call that 0, -2. And if you wanted to find the x-intercept, what you could probably do, tab, we'll go to menu, table, we'll say remove table. If you wanted to find the x-intercept, you could probably select tab, 0, enter. And then, of course, we want to find where they both intersect, so we go to menu, analyze graph, intersection, left and right. And you notice that the intersection will be at 8, 0. So the x-intercept is at it's at 8. It's at 8. So the x-intercept is 8, 0. Let's go ahead and graph this. So let's go to the menu, or let's go to the on button, and we'll type in new. Let me show you how to graph this. So you're going to go to your second control, hilltop. Of course, the index or the root is 3. And then we have x -1. And what's going to happen? What can we say? It's going to move to the right. So let's go ahead and press enter. And it does move to the right. Let's go ahead and draw this on our graph. So we'll go to menu, table, split screen, and let's go to 0, -1. So let me draw the y-axis, and I'll draw the x-axis. Let me draw it again. So we have 0, -1. That's going to be the y-axis, the y-intercept. 1, 0, and 2, 1. So it looks like this, right? And I try my best to draw that. So let's go ahead and identify the domain. Once again, the domain is all real numbers. The range is, once again, all real numbers. The x-intercept is 1, 0, and the y-intercept is 0, -1. And we did say that this will shift to the left. And if I were to draw the parent function, I just have to press tab, control, and we're saying cube root of x, and you notice, you'll see what happened to the graph. It did shift to the right. Okay.